We've seen an example of a large language model at work, and the results are pretty impressive. But how do you go about training a large language model? And that's what we're going to look at in this video. Initially, the language model has random weights, and at this point, the model has no knowledge of language. Now, if you were to prompt it, it would just return gibberish. But if you train the model and passing it a large corpus of data, it adjusts these weights as part of the training process. And this pre-training stage is very resource heavy, so you need lots of data, and this includes a variety of different types of data like books and articles and websites. Let me give you an example. Llama was a group of language models that were released in 2023 by Meta, and this is a data mixture of Meta used for pre-training. So Common Crawl and C4 are web scrapes of the internet that have been cleaned and filtered. GitHub data is programming code like Python or JavaScript. This is code that has been released under certain licenses like the Apache license, giving you the permission to reuse the code for nearly any purpose. And Wikipedia is the well-known online encyclopedia. Books is a collection of open books. So this includes freely accessible to everyone like the Project Gutenberg Books Library. Archive are scientific articles and papers, and Stack Exchange is a network of websites with questions and answers across different topics. Now, a proportion of each of these datasets is sampled given by the different percentages when training on the data. So the epochs give you an idea of how many times the language model saw this data while training. For example, with the Common Crawl, the language model saw all of the sample data 1.1 times, it saw the C4 sample data 1.06 times, and so on. Now, you'll also need a lot of compute. This is processing capability in these massive server rooms where you have several hundreds to thousands of hardware accelerators in servers that you'll use for a couple of weeks or months that works through the training data. So these hardware accelerators are usually NVIDIA's GPUs or graphical processing units. These are like CPUs that you'll find in a computer. Their function is to run a lot of the language model training tasks in parallel. Now, a training run usually costs a couple of million US dollars, and what you'll end up with is something like OpenAI's original GPT-3 model called DaVinci. Let's take a look. So here I am in the OpenAI playground, and let's try and use this GPT-3 model as an assistant. Now, I'm going to write the prompt, write a shopping list. I have no idea what the output will be because it's probably seen thousands of sentences that start write a shopping list, and it could generate anything that's related. Now, what's really impressive is that you can see that after all the training the language model has gone through, it can generate English sentences that make sense. Unfortunately, it's not particularly helpful, right? What I was hoping for is that it would provide me a list of items, one on each line. Instead, what I've got is make sure you always use an app on the phone so you don't have to write down all of the information and so on. So let's see if I can try and trick the model into generating what I want by rephrasing my prompt. So here is a shopping list. And let me go ahead and use a colon at the end of that. And let's see what output we get. Now, this isn't much good either. So what I've got generated from the model is current contracts with the following teams, Carnegie Hall and New York Philharmonic. The Pops appear at Carnegie Hall every season and so on. Now, since this hasn't worked, let me go ahead and try and give the model an example of what I'm looking for. So this is a shopping list of only fruit, and I'm going to list apples, oranges, and grapes. This is a shopping list of only vegetables. And I'm going to leave the large language model to complete the rest. And I'm hoping that it's going to give me a list of vegetables. So let's see what output we get. And you can see that the large language model has been reasonably successful. It's only listed me one vegetable. It's a carrot. But it's then gone ahead and said this is a shopping list of only meat. And it's listed me with chicken. So the language model starts off well, but then it seems to lose the plot and it generates some other text. All right, so we've seen that the pre-training step is a very compute-heavy and expensive process, including a lot of hardware and data. And what we get at the end of this is a model that's good at generating and completing sentences, but it isn't great at following our instructions. So if we want to be able to use language models as virtual assistants, we'll need something that follows our instructions. And so we'll look at how to do this next.